We're going to look more into alkanes and in particular looking at the reactions of alkanes. But before we do that, let's look at a little bit of vocab as well associated with organic chemistry. We're going to use the word saturated with respect to hydrocarbons, and what we're dealing with there are compounds where there are single bonds between each of the carbon atoms. So in a hydrocarbon, you've got the maximum amount of hydrogen atoms around each of the carbon atoms, obviously to give its quadrivalency. And if you've got double bonds or other multiple bonds, they are not saturated. We'll describe those as unsaturated. So we're going to look at the chemical properties. And alkanes, for the most part, are unreactive, but they do undergo some very important reactions, and one is combustion, and they burn, so they have been fuels for a century or a couple of centuries, and useful. They also react with the halogens. So we're looking at combustion reactions, and with the halogens we're going to look at substitution reactions. So the first thing with combustion, we're going to look at complete and incomplete. Complete combustion is with all of them reacting with oxygen, but you've got plenty of oxygen, sufficient oxygen, and you're going to burn CO2 and H2O. So with all combustions you're forming water, but with complete combustion you form carbon dioxide. Here it says review the test for carbon dioxide, where you have carbon dioxide reacting with lime water and forming a milky precipitate of calcium carbonate. And water, probably not going to collect enough to determine its boiling point exactly, so we're going to use cobalt chloride paper, which goes from anhydrous pink to hydrated blue, which is described here. So complete combustion, you're making carbon dioxide. With insufficient oxygen, there might be some CO2, but that's not going to be the major product. Incomplete combustion will form carbon monoxide or particulate carbon, and still water as the other product. Carbon monoxide, here's an equation where it completely goes to CO, where we've got 4 oxygen molecules reacting instead of 7 for the complete combustion. And it's poisonous. Not just a suffocating gas like carbon dioxide, it actively attaches to hemoglobin, and it's not reversible. So it then stops any oxygen being taken up by that particular red blood cell. If you produce carbon, you can see it because the particles of carbon are glowing yellowy orange. That's the flame. So there's some incomplete combustion as soon as you've got the yellow flame. So looking here, it says methane and ethane with 2 of the halogens. So it's 2 of the alkanes, the 2 smallest alkanes, with 2 of the halogens. What we look at here is methane with chlorine, but obviously transpose the halogen for bromine and extend the carbon length 1 more for ethane. So the substitution reactions, what do we mean by substitution? You're replacing a hydrogen on the alkane with a halogen atom, and they're going to be successively replaced. So we're going to use, it occurs using a free radical mechanism. You've met that chemistry before, so this is good review. And we have to make the free radical. And if we look at chlorine, covalent, homopolar, when you draw it, you see the shared pairs of electrons in the middle, but it can undergo two types, heterolytic fission, homolytic fission, depending on where the electrons go. The electrons haven't got bigger with the bigger blobs on the homolytic fission. That's just so you're going to see them more easily. So you've got a chlorine atom, which is a very reactive species. So that's what we're going to look at with the breaking of the chlorine bond. We're going to look at the lower one forming these free radicals. And it requires energy. So we put the H nu, E equals H nu. Nu is going to be the frequency of if it's light energy that's decomposing this. And the free radical, it's a reaction. It's known as an initiation reaction because it's starting off the mechanism with the free radicals. Once you've got free radicals from the initiation reaction, they can react, and if the reaction produces another different free radical, we call that propagation. And here are a couple of them. And in the first one, the chlorine radical is replacing one of the hydrogens, taking it to make hydrogen chloride gas, and you're left with a methyl radical. The methyl radical, once formed, can react with chlorine and produce chlorine radicals again, not just from breaking down Cl2. And what's the name of that product? It's methyl chloride. Here's a further one, further propagation reaction, and other ones are forming, here's methyl chloride again, and the lower reaction here, you're forming, dichloromethane. And the reaction eventually will stop when two free radicals react together, and here you're making HCl, and other termination reactions produce the other products of the substitution reaction. So you've got, in the reaction, you've got a variety of products. You've got the chloromethane, dichloromethane, trichloromethane, which was previously known as chloroform, which you may have heard of, and tetrachloromethane. And the activity is to identify the products of bromine substitution with ethane, identify the initiation reaction, a couple of propagation reactions, and a termination reaction. So thank you. We all know WIS chemistry rocks.